Hello, this is a recorded demo for IRIS agents. It's a Python framework that I built to create agents and orchestrate them on top of InterSystems IRIS. This would be a framework similar to Strands by AWS or ADK by Google or LangGraph and so on and so forth. Let me share my screen and get started. Well, at the core of it, the library is really contains a few different elements. So it contains agent, production, chat, toolkit, and prompt, which we'll look at in this demo. We'll use Pydantic base models as the base model for structured outputs by our agents. So this is how we import them. For the toolkit, I have two different MCP servers running externally in my computer. One of them is utilities, serving weather tools, calendar tools, things like that. Another is Iris, which contains tools like SQL queries and things like that. This is how we'd instantiate a toolkit. And this toolkit framework will help us assign conceptual tools to agents. The chat API is really about persistent content. So imagine you'd have a conversation. The next time an agent is doing a stateful call, it should build the context based on the context provided. So the chat interface is about maintaining this context and so on and so forth. So this is how the object would look like. In a very Pythonic way, I can do context.messages and get the messages out of it. I can also do a call, like when I do chat travel without any messages alongside it, it's going to do a fetch only chat. So if I do this, it's going to match the object that we created earlier. The prompt API is about managing and building prompts. So for instance, in this case, we are creating a variable called bond system, and we are naming the prompt agent 007. In the text, we say you are agent name, you always stay in character. Now, agent name in this case is a placeholder. What we can do with this is we can build this in runtime. So I can do bond system.build agent name equals to James Bond. This gives us you are James Bond, you always stay in character. Now I can use this to manage or version control my prompts. So I can do bond system agent 007, same name as before, and a new text. So instead of overwriting the old text, it will create a version 2 of that prompt. That's interesting, right? Because now I can not only I can do equivalence, this equivalence is working because just fetching prompt agent 007 fetches the latest version of the prompt. So in this case, it's version 2. I can also look at older prompts like version equals to 1, and this gives me the older prompt. What enables me to do with this is I can do a A/B test with different prompts and see which ones are working better, which ones are more accurate, what kind of context is more relevant to aligning behavior to our use case. I can also do things like .get variables. This gets us all the variables from that prompt. In this prompt, you see there's only one placeholder agent name, and that's what we get back. As a developer, this is helpful because I can get to look at all the variables I need to build a prompt fully. Now I can also look at a .delete. So .delete really deletes the prompt from the database. Now it would say no prompt found for agent 007. This is the fetch mode. Now in agents, the agent API is really about the conceptual idea of an agent. So at the very least, it needs a name and a model. In this case, we're naming it Molly, and we're giving it GPT-5. We need to add an agent to a production before we can call it or use it. So I'm making a production called agent space, and I'm instantiating with this one agent. When we call .start, this creates the production and starts at the production in the backend in Iris. So if we run this, it's going to create all the classes required for both the agent as well as the production, and before it starts it. So conceptually, every agent in Iris agents is construed as a business process. So every agent has its corresponding business service agent gateway, and every tool or toolkit or LLM endpoint would be construed as a business operation. So as we see, it took some time, it got us back some results. Let's look at what that looks like. So this is how our production looks like. The agent is the process, the operation is the LLM, and the service is the agent gateway. So if we go to the message viewer, and if we look at the latest message, this is how it would look like. So Molly Gateway sent the message from the user. Now Molly, which is the agent process, would construct the system prompt and the kind of idea of what the tools it has and things like that, and how to respond, the response format we expect out of it. This is obviously enforced by structured outputs at the LLM layer as well. So the LLM responds in a certain format. Is tool is false. This is not a tool call. It's a direct reply back to the user. And so the agent parses that and returns us that value. So this is how we get this. Now, when we make agent Molly, it's also going to do a fetch because we are not specifying the model. So this is in fetch mode. And this object would be equivalent to the object we created before. Now, so far, this has been a very simple agent, right? All it did was do an LLM call and come back. But agents really are more useful when you can have agents do certain tasks. So in this example, we are going to use a structured output. So for two agents, we're going to create two agents, Alex and Molly, and we are going to assign a structured output to each of them. So Alex will have Alex response, Molly will have Molly response. Both of these are pydantic base models. I can also specify a system prompt for each of them. I can specify a reasoning effort, which is by default, and I can specify the response format. And now these configurations can be changed at runtime as well, as we will see. So this is going to create the two classes in the backend in ObjectScript. The Python developer never needs to worry about the ObjectScript backend. When I do .start, by adding these two agents, it's going to set the OpenAI key, it's going to start the server, it's going to do all of that stuff. Now if I say, for instance, what tables, actually before this, let's look at the production, how it looks like, right? So the production now looks like this. So we have Iris, OpenAI, and utilities. These two are the toolkits that we've provided. Alex and Molly are the two agents. They both have their respective gateway services, right? Now, when I say which tables do we have in Iris in the agent's namespace, for instance, let's see what happens. Great. We get a text, SQL user test model, reasoning, I queried the IRIS system, right? How did it get there? How did it find the SQL user test model, right? So let's see what happened in the backend. So if I go back to the message viewer, I can look at this particular message. So what's happening here is Molly Gateway sent the request to the agent, right? Now Molly has new system prompts, new tool descriptions, things like that. OpenAI responds, like the OpenAI business operation responds with is tool is true, meaning this is a tool call, toolkit is iris, list tables, namespace agents. These are the parameters for the tool call. Now, Molly, after receiving it, would make the tool request to iris, which is the toolkit, with list tables and the namespace agents, and it would get back some result out of it. Now, we can see in the result, it responded with type text. Text is SQL user.test model. Now, Molly passes that back to OpenAI, and OpenAI responds with whatever it responded with, right? And this is what gets sent back to the user. So this is how we get this. Now, I can also invoke the tool in a direct manner. So I can do molly.use, right? So .use is the method we will use to invoke a tool deterministically. So we can do molly.use toolkit is equal to iris, tool is query, parameter is namespace agents, SQL is select star from agents.agent. So this is really using this tool, this SQL statement, and running it on this particular tool query, right? So this is what we get out of it. So this is a direct tool call. Now I can also do things like Molly message what is the weather today. Now this is going to use the other tool that we have, which is utilities, which has a weather tool. And this is currently deterministic. This is text that it takes in the city name and it responds with the right information. And we can see today in Washington, D.C., cloudy, high 26, low 13. Now, how did it know about Washington, D.C.? I never really specified it. But notice we are now calling it with chat equals to context. Now, context is a variable we made much earlier over here. Here we have in that context, we are in Washington, D.C. So because we said chat equals to context, it had the context about which city we are in, and it could make the right tool call to get the right result, right? So that's how it used the provided weather tool for Washington, D.C. Now we can also override some stuff. I can run Molly message equals to recommend some good food spots for lunch. Chat equals travel, which means it's persistent, stateful chat, and reasoning effort is high. So usually, like Molly by default, if you look at the signature, it uses a reasoning effort of low, right? But because we are overriding it, we can override it at runtime and get some result that's different. So we'll see that reasoning effort is going to be high, it's going to take more time, it's going to return more reasoning tokens. And by the way, in the back end, we are also logging this reasoning tokens and the reasoning traces, also the encrypted reasoning content that is sent out by OpenAI API. So this helps us observe the system, analyze the system after the fact. So we can run data science, we can run analytics on top of that information for building and iterating upon the systems we're trying to build and optimize. So let's see what it says. Great. So here are some great lunch spots in Washington, D.C. Again, it's using the context from chat equals to travel, right? So you can pass it as a variable of the chat object, or you can pass it as a string, which it will fetch automatically, right? Now, if I want to do a structured output that is not this text in reasoning, so this is Molly's default mode, right? So it's responding with Molly response. This is its default. Now, I can also say, for instance, more complicated structured output. I can say class restaurant, right? It's a pydantic base model, and class taste atlas contains restaurants as a field, which is a list of restaurant type objects. So it's a nested pydantic base model. Now, if I do this, what I get in return would be taste atlas type of response, not the Molly's regular response, right? So I can say what are some places I would like. I tend to like Italian and Asian cuisines. Now it responds with a certain format, which is the taste atlas format, which is response restaurants. Each restaurant is its own restaurant, things like that. Now I can also look at chat travel dot usage. So when I do chat travel, it's getting me the chat. And when I do dot usage on chat production agent level, I can get the input tokens, output tokens, total tokens, things like that, output reasoning tokens. And this happens at different stages. So production, I can do that at the production level. I can do this at an agent level, and so on and so forth. For productions, I can also filter by which agents do I want to look at. So this is saying from production agent space, give me the usage for agent Smalley. So I can look at that as well. I can also do production. So right now, you see this production configuration. This is working because the production is still up there. Now, if I do production agent space dot delete right here, it's going to delete the production, right? And now if we try to reload this page, it's going to say invalid production was selected, right? Because it doesn't exist. Same with Molly. We can delete the agent and it will delete all the backing classes which is written in object script. So this is a brief overview um, of the Iris Agents framework, and the idea is you can build, observe, and trace agents, manage prompts, all of that, all backed with InterSystems Iris. Thank you.